Hello, this is CG5042. This is the second lecture we're going to cover, and my name is David.Newport at the University of Limerick. So in the first lecture, we have been covering the design process, and we spoke about the kind of flow chart that you would have with this. And I suppose the key thing that we pointed out was this need for specifications, that when you get your design brief, that you really need quantified, specific definitions of what it is you want to achieve. And you use these to assess whether your design has met these needs. So they give you a number against which you can check it. We then spoke about the preliminary design phase, where you develop different concepts and the different design philosophies and methods you can use to be creative in this respect. And we're just getting to the stage where we're at the scoring and evaluation, where you select one of these. You then enter a detailed design phase where you're now putting in a lot of resources, and then you increase resources further by trying out a pilot plant and scale up, etc. Okay, so we've gone through some of this stuff and looked at different forms of, looking at design. We have the formful of functions, lateral thinking, biomimicry, and different techniques you can use. So we did a study in class on brainstorming and identified some of the limitations of that. So what I want to focus on in this lecture is really the scoring matrix, which we see here in red, and also the priority matrix. Now, the priority matrix comes before the scoring matrix. So that is where we assign priority to the criteria used in the scoring matrix. Okay, so in the scoring matrix, we're going to look at giving scores to the different designs under different headings, different criteria. And the priority matrix helps us quantify which one is more important than the other. So which one should we give a bit more weight to? So that's the objective really with the priority matrix, is to underpin the scoring matrix. So this is an example of a scoring matrix. We got 3 designs, design A, B, and C, developed by different design teams, or maybe the one team has come up with 3 different concepts they wish to evaluate. And we have a selection of criteria here. And these are some of the typical criteria that we would have, for example, safety, cost, maintenance, energy, environment, footprint, noise, reliability. There may be others, and you need to define what these criteria are coming from your particular specifications and the peculiarities of your design scenario, what you are designing for. So in our case, what we've done is we've scored each of these 3 designs across each of the categories. So safety, for example, it's got a weight of 10, and we can design A a score of 10 on that, design B a score of 7, and design C a score of 6. And we do the same things, for example, on noise. It's not a very important consideration in this particular setup. Design A scores a 10, design B a 6, design C a 4. So we sum up all of these vertically, and we see that design A gets 240, design B gets 271, and design C gets 236. So in this case, design B is the winning design, and that is the one that will be developed further. So in essence, what we're seeing with the scoring matrix is that it gives us a way of objectively quantifying the differences between the designs under specific headings that should tie back into these specifications. A more cynical way to look at it is a way of covering yourself. So you're not designing based on whim. You haven't gone with something because someone likes a particular design. For example, if someone is pushing design A, you're saying, well, look, we've scored this objectively, and design A just can't do the job. Design B is much better doing the job. So it is a way of providing a quantified basis for selecting your design and making that objective and leaving out the feeling side of things. Okay, so again, we have this here. It gives us numbers. It helps us to resist human or personal bias by reducing arguments down to numbers, and it establishes this perception of objective assessment. Now, that's a perception. You can also use this in a manipulative way to get what you want. And what you do is you end up reducing arguments down to numbers. So, okay, you don't like design B. Well, okay, what's wrong with design B? Let's go back and let's check it again. I've given it a 10 on maintenance. So am I wrong in that? Should I have given it a 7? Should I have given it a 6? Well, let's give it a 6 and put it in and see what the scores are. Okay, you see we'll lose 12 points there, which is still insufficient to lose. So you can use it to kind of reduce arguments in this based on particular designs down to numbers and use that to your advantage. So it is something that can be manipulated, but the overriding basis for it is that it is giving you numbers and you're supposed to be objective in deciding those. Now, the different criteria that we had. So if we go back to slide 8 here, we have the different criteria that we listed out. And I've given these weights assigned to these. Excuse me. So we can see that safety has a weight of 10, footprint has a weight of 1, energy has a weight of 5, maintenance has a weight of 2, cost has a weight of 5. So these are weightings that have been assigned to the different criteria that give the relative importance of these criteria. And first and foremost, we can see that safety is the most important, and that will always be the case. And it is your moral and ethical responsibility as an engineer to ensure that is the case. So don't ever take part in a design where safety is not the first priority, the most important priority. A lot of students think that cost, is really, really important, and it is because plants have to make money, but overriding safety. And that you have an obligation as an engineer to prioritize safety. So what a priority matrix does is it gives us a way of deciding which ones are more important. So what we do is we set up this kind of a triangular table. So we have a vertical column here, which lists our criteria. And then we have these columns here. You can see how that should do with the red pointer, hopefully. We have the same ones listed across. And what we're doing here is we're picking number in each one. So safety is number 1, cost is number 2, size is number 3, etc. down to noise is number 9. And we now directly compare cost with safety. Okay, so we come across cost here where it intersects with safety, and we're looking at this point here. And safety wins. So 1 goes in. So safety is more important. Then we have size compared to safety. Safety is more important. So number 1 is entered. Installation, number 1. Reliability, number 1. Environment, number 1. Maintenance, number 1. So we can see that safety is winning every single comparison here against the different criteria. And again, I have written up here, safety always ranks above all other criteria. And do not participate in designs where that is not the case. Then we move to the next column. So now we're looking at cost. Now we're going size versus cost. So 3 versus 2. Well, 2 is more important. Cost versus installation. 2 is more important. Reliability versus cost. Well, the reliability is more important in this case. Environment versus cost. The environment is more important than the cost. Maintenance versus cost. Cost is more important. Energy. The energy is more important than the cost. Noise. Cost is more important than the noise. So we keep doing this. If we go to column 3, and we see that we've got installation is more important than size, reliability again, etc., etc., etc. And we do this one-by-one comparison with all the different criteria until we populate the table. Now what we do is we count the number of occurrences of the different criteria. So if we take safety, for example, what we're going to do is we're going to count the number ones. So 1, 2, 3, 4, 5, 6, 7, 8 number ones. So safety has a count of 8. Cost has a count of, so we just count up the 2s, 1, 2, 3, 4. So 4 for cost. Size number 3, we don't have any number 3s anywhere inside this matrix here. Installation is number 4, so we're looking for number 4s. We've got 1, 2, 3. Okay. Reliability is number 5, so we're looking for number 5s. 1, 2, 3, 4, 5, 6, 7. Okay, etc., etc., etc. So based on that, we now have the priority established. We have safety is the highest, followed by reliability, followed by, where are we? Energy is 5, cost is 4, environment is 4, so they have equal weighting. Installation and maintenance are 3, so they have equal weighting. and we've noise, size, and noise and size as the lowest weight. Okay, so that's how we establish then the priority of these terms. So when we go back to our scoring matrix, we now have a basis for establishing these. Okay. And again, when you're doing the scoring matrix, you can go back and you can argue down and say, well, okay, you're saying the cost, the weighting is off here a bit, it should be more important. Well, let's make it more important and let's see what it does to the scoring process. Okay. So that, in a nutshell, is how we establish the weighting that we would assign, or the priority that we would assign to different parameters, and then use the different designs, or score the different designs to come up with the preferred design option that we'll then put a lot more resources into. So going forward then, we would look at reliability, materials and corrosion, and then piping systems. Thank you for listening. I hope you found that useful.